Hey guys, in this tutorial I will show you how to set up a calculation using Avogadro, how to run the calculation with ORCA, and then we'll look at the output and then finally look at it in 3D. So let's begin by drawing our molecule. I'll open Avogadro and today we will work with, what will it be? CO2. So you can draw it pretty much as ugly as you want, because before proceeding we will optimize it using MM. And now this is much better. So now we're ready to make the input file. You go into extensions, scroll almost all the way to the bottom where it says ORCA, and then click on generate ORCA input. Here you have basically two tabs. You have the basic one and you have the advanced. If you want, you can go into the advanced, so that gives you additional things like what DFT do I want to use, all by clicking around. If you don't like clicking around, you can just type it out here yourself. And now it's begging for the question of like, well, how do I know the keywords that are there? So you can Google ORCA manual and you will get this beautiful 300 something pages user manual, which is a lot of information, but the most important sections are section 3 and 5. So take a look at that. They do a very good job at explaining where everything is, and it's filled with examples. So if you don't know how something works, just scroll in and look at, just copy paste some headers and you'll see it's pretty trivial. So for us, because an example, I don't really care, I'm going to do RHF, it'll do. With default basis set, it'll do. But the one thing that I do want to add is these lines over here. Normal print to print the basis set and the molecular orbitals. So over here, just gonna copy paste that in here. So what does this do? These lines I found that were necessary if you want to have the possibility of looking at the molecular orbitals using Avogadro. If I don't put these lines for my version of Avogadro, at least, I can't see them. They're in the output file as numbers, but for some reasons they don't get translated into images. I don't know why. So now if you're ready, you can just click on generate here at the bottom and save as input file anywhere you're comfortable with. So I already have a folder for ORCA. You can save it anywhere you want. So I won't do it because I already gonna have my input. So I'm just gonna go ahead and use it as is. So now let's open the command line, click on run, type in CMD, click on OK, and the command line appears. Now I will have to navigate using the command line into the folder where my input file is. So for me, it's in the folder on the desktop, so I have to change directory to desktop, ORCA docs, and I will write dir to see what kind of files sorry, are already in my directory. So now my input is there. Perfect. Now I'm ready to run my calculation. So I'm going to type ORCA CO2 opt.imp, channel the output to CO2 opt.out. Okay, and then when you're ready, you just click on enter and your calculation will run. So I'm going to skip that for the sake of time. It doesn't take long, but it still takes some time. So I'm just going to show you kind of what the output files are and what to do with them. The output files. There are several of them. The most important one is a .out. That's kind of the summary of everything. It has all the parameters used, all the additional information. Most of everything that you want to see is there. But you have additional ones. For example, the very important GBW file that contains the information for a restart. If you have a calculation that crashed and you don't want to restart from scratch, you want to use the stuff that you already calculated, right? You will need to use this GBW file to help your input. Okay, then you have the trajectory file, which lists different coordinates of your molecule as it evolves through your optimization. And then you have the XYZ file, which is basically the coordinates of your final molecule. So now let's take a look at the .out file in the text format. Okay, I already have it all the way to the bottom. No good. Okay, so we always start off with the acknowledgements and the name and a whole bunch of people who worked on all of this. Thank you, people. You guys are wonderful. Then you have your input copy, and then starts your geometry optimization run in different cycles. So you're just going to scroll through all of that. If you just want to check whether your optimization was successful or not, you can do Control F and search for the word hooray. Because if your optimization was successful, you will see hooray, the optimization has converged. So everything worked out. Perfect. And if you scroll all the way to the bottom, the last message you get is ORCA terminated normally, which means that all the files that were supposed to be created were created and all the temporary files have been erased. So you don't have to take care of that. Okay, now we are ready to look at our output using Avogadro. So what if I want to see what it looks like? I'm just going to discard the input and open another Avogadro window. And I want to pull the .out into my view pane. Alright. So here you can notice right away that because we have added those specific output keywords, my molecular orbitals have been automatically loaded here on their own, which is kind of convenient. Now, for example, the HOMO looks like this, the LUMO looks like this, HOMO -1 looks like this, etc., etc. Don't forget that you can change the way everything looks by either clicking here on configure. So here you can change the ISO surface value and the quality of the orbitals. Or if you want to render them differently, then you can go on the left here, scroll to surfaces and click on the little wrench here. And here you can choose the colors, the rendering. So do I want fill or points? Let's make it fill. You can change the transparency, etc. So play around, have fun. I hope it works out for you, and take the time to explore the user manual, which is beautiful. But there's also this website. It's a wiki website, Google website. I'm sorry. Why don't you just scroll to the top? Why My computer is going nuts. Okay, let's do this. We're on the top. Okay. No. This is not funny. Okay, forget it then. Just Google ORCA input library, and it's a very good. There we go. Success. It's a very good alternative for the user manual. It's more visual and it's separated in different pages, so it's not like all together looking at you with all of its 300 pages. It's a bit more laid back. So take a look at that and explore, have fun, and I hope it works out for you. See you next time.